How to find the GCF of numerical coefficients. Imagine you're working on a math problem and want to make it easier by simplifying it. One way to do that is by finding the biggest number that divides all your coefficients evenly. This process is called finding the greatest common factor of the numerical coefficients. It might sound tricky at first, but once you understand the steps, it becomes quite straightforward. First, look at all the coefficients in your polynomial. Write them down clearly. For example, if your polynomial has terms with coefficients 3, 6, and 9, list them as 3, 6, and 9. Next, break each of these numbers into their prime factors. Prime factors are the smallest numbers that multiply together to make the original number. For instance, the prime factors of 6 are 2 and 3 because 2 times 3 equals 6. The prime factors of 9 are 3 and 3, because 3 times 3 equals 9. Once you have all the prime factors, look for the common factors across all the numbers. In our example, 3 appears in all 3 sets of prime factors. The number 3 is a common prime factor for 3, 6, and 9. Now multiply all the common prime factors together. Since 3 is the only common prime factor, the GCF of 3, 6, and 9 is just 3. This method works well for any set of coefficients. For example, if you have 24 and 36, break them down into prime factors. 24 is 2 times 2 times 2 times 3, and 36 is 2 times 2 times 3 times 3. The common prime factors are 2, 2, and 3. Multiply these together. 2 times 2 is 4, and 4 times 3 is 12. So the GCF of 24 and 36 is 12. When working with polynomials, after finding the GCF of the numerical coefficients, you also consider the variables. But for now, focusing on the numbers, prime factorization is the easiest way to find the GCF. This step is essential because it helps you simplify the polynomial by factoring out the GCF. When you factor out the GCF, the polynomial becomes easier to work with and makes solving problems much faster. Remember, the key is to break each coefficient into prime factors, find the common factors, and multiply them together. This process is simple, reliable, and a great foundation for more advanced factoring techniques. So next time you see a polynomial with multiple coefficients, try prime factorization to find the GCF and make your algebra work smoother.